Alright folks, let's take another look at inverses. We did them in Unit 1. Let's just recap and then we're going to look at quadratics a little bit more closely. First one that we want to look at is given a set of points, and recall that the inverse of a function is when x and y trade places. And that's all we're doing. So if I gave you a set of points, if I said f of x is equal to the set of, I don't know, 1, 2, and 3, 4, not very creative, that's okay. My inverse, remember, is my fancy notation, f to the minus 1 at x is equal to 2 comma 1 and 4 comma 3. So all I've done is just put x's and y's in the opposite spot. X and y's trace places. Let's now try this for the linear function. We're going to start with the function f of x is equal to x minus 5. Step 1, write y instead of f of x. So we're going to get rid of our fancy notation and we're going to write it as y equals x minus 5. Step 2, we're going to trade x and y. So we're now going to write it as x equals y minus 5. Step 3, we're going to rearrange it so that y equals everything else. So instead of minus 5, we're going to do the opposite. So we're going to add 5 to both sides. So we now have x plus 5 equals y. And our last step is to write it in our fancy notation. So that means that our inverse, f to the minus 1x, equals x plus 5. Okay, let's try another example. Let's do f of x is equal to 3x. Okay, let's still follow our steps. So step 1, write y instead of f of x. Y equals 3x. Step 2, let's trade x and y. So I've now got x equals 3y. Step 3, rearrange so y equals everything else. Let's see, instead of times, let's divide both sides by 3. So what do we got? We got x over 3 equals y. Oh, time for step 4, fancy notation. F inverse x equals x over 3. Let's now try to find the inverse of a quadratic function. Let's start with our base function, f of x is equal to x squared. Follow our same steps, so we write down y is equal to x squared. Instead of y, we write x. Instead of x, we write y. Now we have x equals y squared. To get rid of the square, this is the important part. When we take our square root, we need the plus or minus. Final answer will look like plus or minus the square root of x is equal to y. Fancy notation, f inverse of x is equal to plus or minus square root of x. And why is this plus or minus important? This is incredibly important when we go to do this. I have here decimals, and I just typed in f of x is equal to x squared, so that's my green picture. My red line is just positive square root of x, and notice how it's only got half of the picture. To get the full picture, we have to include the minus side as well. So we need our plus and our minus. There's my inverse. Okay, let's do another example. Let's say f of x is equal to x squared minus 3. Follow our steps. We're going to write y instead of f of x. So we have y equals x squared minus 3. Step 2, trade x and y. So I've got x equals y squared minus 3. Step 3, we're going to rearrange so y equals everything else. Well, let's do, instead of minus 3, let's do plus 3 to both sides. So I have x plus 3 equals y squared. Now to get rid of our square, we're going to do our plus or minus square root. And now I've got plus or minus the square root of x plus 3 equals y. Time for our last step, our fancy notation. F inverse of x equals plus or minus square root x plus 3. Because this algebra is so much fun, let's do another one. Let's say f of x is equal to 5x squared plus 4. Still following our steps, we're going to write that as y equals 5x squared plus 4. And then we're going to write x equals 5y squared plus 4. Time to rearrange. We're going to minus 4 from both sides. So I now have x minus 4 equals 5y squared. Divide both sides by 5. So I have x minus 4 over 5 equals y squared. Last but not least, let's take our plus or minus square root. Plus or minus square root x minus 4 all over 5 equals y. Fancy notation time. F inverse of x equals plus or minus square root x minus 4 over 5. Done. Let's do another example. F of x is equal to bracket x minus 3 all squared. So this time now I have my number on the inside. We're still going to follow our steps. So y equals bracket x minus 3 squared. X equals bracket y minus 3 squared. Now it's time to rearrange. Because my square is on the outside, I have to square root everything first. Let's rewrite. So I have plus or minus the square root of x equals y minus 3. Now I'm allowed to move the plus 3, but I couldn't do it before. It was underneath the square root. I had to get rid of the square first. Now I've got plus or minus square root of x plus 3 equals y. Time for our fancy notation. F inverse of x equals plus or minus square root of x plus 3. Note that that 3 is not under my square root, so I could have written it as 3 plus or minus square root of x. Okay, now I think we are ready for example 2 on page 157, where f of x is equal to 2 bracket x plus 3 squared minus 4. Let's follow our steps. Y equals 2 bracket x plus 3 squared minus 4. Instead of y, we write x. So I have x equals 2 bracket. Instead of x, I write y plus 3 squared minus 4. Let's rearrange. We have to move that 4 first because it's the farthest away. So I have x plus 4 equals 2 bracket y plus 3 squared. Next move is the 2. So I now have x plus 4 over 2 equals bracket y plus 3 squared. Now I'm going to get rid of my square. So I need my plus or minus square root of everything. So I have plus or minus square root x plus 4 over 2 equals y plus 3. Shrink that up a little bit so I've got a bit more space. Last move is the 3, so I'm going to minus 3 from both sides. And we've got plus or minus square root x plus 4 over 2. Minus 3 is outside the root sign equals y. Therefore, f inverse of x equals the plus or minus square root x plus 4 over 2 minus 3.